sequence of instructions used for solving a problem is called an algorithm. We can have different algorithms for solving the same problem. There are some properties for an algorithm. They are: the instructions used should be in simple language. Every instruction should be precise. It should not gather any doubt. It should not repeat infinitely. It should conclude or stop in a finite number of steps. And we should have some result after completion of an algorithm. As I said, there are different algorithms for solving the same problems. We can rank an algorithm based on their quality. The following factors are considered to judge the quality of an algorithm. One is the time taken for completion of an algorithm or execute the instructions. Whichever algorithm takes lesser number of steps is considered the better one. Similarly, the memory, the space used for execution of the instructions. Here again, lesser is the better. Accuracy. Multiple algorithms may provide different answers. One may be accurate, the other may be less accurate. Whichever is more accurate is considered to be the better one. This is a simple example. If you want to print a text, "Good morning," we are starting the algorithm, printing the message, then stopping. A simple, very simple algorithm. We can divide an algorithm into different blocks. They are statements, then state of an algorithm, which may change from time to time, the control flowing sequence, and different functions. Let us see them one by one. Statement is a single action performed by a system. It may include the following: inputting data, that is the information given to the program or algorithm; processing them, that is performing some operation on the given input; then producing the result, that is output data. State is the transition from one process to another process under a specified condition within a time. Whenever we perform some operation, the state of the data becomes different. Control flow can be of three types. One is the sequence, that is the one instruction executing after another. This sequence is followed from the beginning to the end. Second one is the selection. At a particular point of time, we may ignore some statements or instructions or select some instructions. Third one is iteration, that is a repetition of some steps. This is an example of sequence of instructions. From step 1 to step 5, all the instructions are executed one by one. Then selection include this one. So you may, based on some condition, if it is true, action 2 is performed. or if it is false, action 1 is performed. So between these two statements, we are selecting one among them. That is the selection. This is an example of selection statement. So either 3 or 4 is being executed based on the condition. The final one is iteration. We may have to repeat some statements again and again for solving a problem. So instead of writing that instruction repeatedly, we can have iteration type of algorithm. This is a simple example to print all natural numbers up to n. So here step 4 is repeated. 4 and 5 are repeated for a particular period of time. Another one is functions. Whenever the algorithm becomes too complicated, we can divide them into small segments. Each segment solve a particular problem or particular task. Such segments are called functions, so that we can represent a complicated task into a group of simple tasks. These are the benefits of using functions. We can reduce the number of lines in the code. Code segments or functions can be reused. It increases the readability. Some informations can be made hidden. It is easy to handle those simplified segments, and it is also simple to maintain each of these segments when compared with the original complicated algorithm. Here we have a main function, then we have a sub function. We can have many number of sub functions. For example, we are considering only one sub function, which is named as add. So we are starting the main function, calling the sub function, and stopping the algorithm. The sub function is add. As in the main function, sub function also begins with a start statement. Then it is reading two values, adding them together, printing the result, and the control is being returned to the calling function. And this process is repeated for every functions we are using. Now this is an example of function calling. Now let us see how we can calculate the number of steps that is being executed. Let's go through the following videos.